Okay, in this video, we're going to take a look at the graphs of secant and cosecant functions. So the secant graph, the cosecant graph as well, have this resemblance of smiles and frowns. So we get one full secant graph or one full secant cycle with a full smile and a full frown. And same thing with cosecant. We get one full cycle with a smile and a frown. Well, looking at the secant graph, much like with tangent, we have vertical asymptotes at odd multiples of 90 degrees or odd multiples of pi over 2 radians. So 90 degrees, then 3 times that, 270, another 3 times that, 540. We'd have another vertical asymptote. 90 times negative 1 here would be negative 90, and then 90 times negative 3, we'd have another one at negative 270, and you get the idea. Notice though with secant we have going up with these vertical asymptotes, there's no maximum and there's no minimum here either. So we don't have a maximum and we don't have a minimum again with secant. Likewise, same thing with cosecant. There's no maximum value, there's no minimum value. Also notice that there's not much going on between -1 and 1 for our graph of secant and our graph of cosecant. With cosecant, much like cotangent, the vertical asymptotes are at multiples of 180 degrees or multiples of pi radians. And starting with 0, we got a vertical asymptote there, vertical asymptote at 180 degrees or pi radians. And in between the asymptotes, we get a smile and a frown. Same thing with secant. In between the asymptotes, we get a smile and a frown. So if we look at the graph of y equals cosine of x and place it in the same graph as secant, we see some interesting features. So in blue, I have the graph of secant with the vertical asymptotes, and in red is the graph of cosine of x. And notice wherever cosine had a maximum value, that's the bottom of a secant's smile. Wherever cosine had a minimum value, that's the top of a secant's frown. And also wherever cosine crosses the x-axis, that's where we have a vertical asymptote, and that's the based on the nature of the relationship between secant and cosine, where the secant graph in blue is the reciprocal of the graph in red. So really, if we graph a red cosine function, we can graph its corresponding secant function by placing vertical asymptotes wherever we have the cosine graph cross the x-axis, and start a smile at a maximum for cosine, start a frown for a minimum in cosine. Same thing with, notice that when cosine's at a maximum, we get a smile, and when it's at a minimum, again, we get a frown on the secant graph. So again, wherever y equals cosine of x crosses the x-axis, there is a vertical asymptote for secant. So rewind a little bit and you'll know why. So the same logic applies with cosecant and sine. So here we have in blue and the graph of cosecant along with those purple vertical asymptotes. Well, here in red we have the graph of sine. And if we take a look at the graph of sine, wherever the graph of sine crosses the x-axis, we have vertical asymptotes. And wherever we have a maximum for sine, we got a smile. Wherever we have a minimum for sine, we have a frown. So some properties of secant and cosecant. Number one, looking at this cosecant graph in blue, there is no maximum, there is no minimum, so hence no amplitude. So tangent, cotangent, secant, and cosecant do not have amplitude. Only sine and cosine will. So the period of graphs or secant and cosecant can be found by determining how long it takes one full smile and also one full frown to appear. And from the graphs, we can see it's 360 degrees or 2 pi radians. So one full smile, one full frown from 0 to 360. So everything has 360 degrees or 2 pi for the period except tangent and cotangent. They have 180 degrees or pi radians for their period. Multiplying your inputs by a positive value other than 1 is going to change the period, and phase shift and vertical shifts are calculated in the same way as the other 4 trig functions. So you really don't need a whole ton to memorize. You have phase shift and vertical shift work the same universal for all 6 of them. Only sine and cosine have amplitude. Tangent and cotangent, their period is pi or 180 degrees divided by what you're multiplying your x or your input values by. So example 2, we'll find the amplitude, period, phase shift, and vertical shift for each. So we have 2 times the secant of x minus 45 degrees. Once again, there's no amplitude. Period 360 divided by 1 is 360. So it takes 360 degrees to get a full smile and frown out of this graph. The phase shift, we said x minus 45 equal to 0, so we get x equals 45 degrees, and it's shifted to the right. And you could do plus 0 or minus 0 after the function if you like. There is no vertical shift, or the vertical shift is 0. Part B, negative 1/3 cosecant x and then plus 1. And again, notice that the plus 1 is not inside parentheses with the x. So no amplitude here. Period 360 divided by this coefficient of 1 in front of the x, which is 360 or 2 pi. No phase shift here, or you could say 0. And the vertical shift is up 1. Example 3, 1.5 cosecant of 2x plus 120 degrees minus 5. Again, no amplitude. Pardon me. 360 degrees divided by, this time, 2 to calculate the period. So we have 180 degrees, or pi radians. The phase shift, which somehow reason is over here, is, we said 2x plus 120 equal to 0. Subtract 120. Divide by 2, we get negative 60. So, again, shifting 60 degrees to the left. And followed by a vertical shift of down 5 units. So, and just to summarize, if you want to pause just to have one-stop shopping for everything in the videos for this section, nice little summary table. Again, no amplitude for anything. Tangent and cotangent are the ones that have the oddball periods, 180 over b or pi over b. Phase shift and vertical shift, the same for every trig function. And here we have secant and cosecant are back to 360 or 2 pi divided by b for the period. All right, that about does it for this video. Thanks for watching, and I'll see you next time.